Okay, so let's try some more problems on forces and mass and acceleration. We're still in chapter 4. Right, a 4 kilogram block is acted upon by 3 horizontal forces as shown in the diagram. Right, we have 10 newtons going to the left here, we have 5 newtons, and then 25 newtons going to the right. Right, so what I want to do is say if I'm going to the left, this will be negative. If you go to the right, you're positive. I could just as easily say this is positive and this is negative. It's just for me to be able to add these forces together because I'm going to do letter A first. What is the net horizontal force acting on the block? Well, I got to add up all the forces. If you're going to the left, you're going to be negative. If you're going to the right, you're going to be positive. So I'm just going to add them up here. So the F net A, the F net, the net force, is equal to negative 10 newtons plus, that's a 10, plus 5 newtons plus 25 newtons. Alright, that's going to be your net force. And I'm going to go ahead and, I usually don't give you the answer, but I'll go ahead and, I think this is 20 newtons here. Positive 20 newtons, right? So that's 20 newtons to the right. That's why it's positive, so that's why it's to the right. Or you can just look at the picture, it's obvious it's going to go to the right. Okay, so it's going to be pulled to the right. That means it's going to have an acceleration to the right. And we're going to solve for that acceleration. What is the horizontal acceleration of the block? So we're going back and forth this way. Which way is it going to go? It's going to go this way. It's going to accelerate this way. What is that? What's the magnitude of that? Alright, so we have a force. I'm going to write everything down that I have. I have a force, a net force of 20 newtons to the right. I have an acceleration that I'm looking for. And what else do I have here? Oh, I have a mass. I know that this is a 4 kilogram block, so I have mass. Hey, I have force, I'm looking for acceleration, I have mass, I can use force equals mass times acceleration. Just get acceleration by itself, so I'm going to divide mass on both sides. It goes to 1, so take the force, divide by the mass, and you'll have, take the net force, divide by the mass, and you'll have the acceleration. So it's going to be 20 divided by 4, and I'll let you plug that into your calculator. Okay, let's try another one. What is the weight of a 40 kilogram mass? Oh, okay, well, weight. Just got to know some definitions here. Weight. Another way to say that is the force of gravity on an object. 40 kilograms is the mass. Mass equals. Well, what's the force of gravity? So if you look in your book, the force of gravity is equal to the acceleration due to gravity times your mass. This is the same. Fg equals n times acceleration due to gravity. This is the same as just our plain Jane equation of force is equal to mass times acceleration. Alright, so we're just saying this is the force of gravity, so it's always going to act toward the Earth. On an object toward the Earth. So write that in. So let's we have the mass. We're looking for the weight, so we're looking for the force of gravity. And we know G. Well, you should know it. You can look it up if you don't know it. It's 9.81 meters per second squared. That's the acceleration due to gravity. So I have 2 variables known, 1 unknown, so I just got to plug into the equation. Equals 40 times 9.81. This is meters per second squared. That's kilogram. That's exactly what I want. The unit that I'll have is, what's a kilogram times a meter over second squared? That's a newton. So your answer will be in newtons. And that is the weight. And it's also the force of gravity. Okay, let's do one more. What is the mass of a 196 Newton weight? Okay, so this time we know the weight, and we know that weight is the force of gravity. That's 196 newtons. We know the mass. Oh wait, no, we don't know the mass. We're looking for the mass. And oh, well, what else might we need? Oh, well, since we're dealing with force of gravity, we know that we're dealing also with the acceleration due to gravity, which is 9.81 meters per second squared. Okay, so I have two variables. I have one unknown, so I'm just going to plug into this equation. Force of gravity equals mass times acceleration due to gravity. I'm going to rearrange it to solve for mass, because that's what I'm looking for. So take your force of gravity. Oh, whoa, I did not solve that for mass. Let me back this up. Okay, I'm going to solve for mass divided by acceleration due to gravity on both sides. There we go. Alright, that's what I want by itself. Now it's by itself. Okay, so take force of gravity divided by acceleration due to gravity. That will get you mass. So take 196 divided by 9.81. A newton divided by a meter per second squared is newtons, and is kilograms. A newton divided by meter per second squared is a kilogram. That's exactly what we want. We want our answer in kilograms. So I'll let you plug into your calculator and solve for that.